Hi students, let's discuss today EM4 in that first concept, inverse function. First let us understand what is inverse function. If a function f from a to b is defined by f equals a comma b such that a belongs to set A, b belongs to set B is bijection. What is bijection? The function f is said to be bijection when it satisfies one-to-one condition and onto condition. What is one-to-one condition? Every element of set A having distinct image in set B, it is one-to-one. What is onto condition? The range and codomain must be equal. So these two conditions, if it is satisfied, the function f is said to be bijection. Now function should be bijection, then inverse function of f is denoted by f inverse from B to A. Here f is from A to B, f inverse from B to A, and f inverse will be defined as B comma A, where A comma B must belongs to function f. If A comma B belongs to f, then B comma A belongs to f inverse. If I give an example, you may understand. The inverse function we will denote it by f inverse. Now, inverse function of f exists if and only if f is a bijection. Already I told, inverse function exists only when the function f is bijection. Remember, you are finding the inverse means check whether the function is bijective. If the function is bijective, then inverse is exist. Now let me take example. Here f is one function, 1 comma a, 2 comma b, 3 comma c, 4 comma d. Here f every first component is domain of the function f. The second component of every order of pair is nothing but range of the function f. One is associate with A, 2 associate with B, 3 associate with C, 4 is associated with D. So 1, 2, 3, 4 they are belongs to set A. A, B, C, D they are belongs to set B. If I consider 1, 2, 3, 4, these are the elements belongs to set A. 1 is related with A, 2 is related with B, 3 is related with C, 4 is related with D. These are set B. This is f function. 1, 2, 3, 4 are said to be domain. A, B, C, D are said to be range. A is image of 1. Image of 2 is B. Image of 3 is C. Image of 4 is D. Now, what is f inverse? So 1 related with A, 2 related with B, 3 is related with C, 4 is related with D. This is my function. Then what is f inverse? Look at this. Every element have distinct image. So 1 to 1 satisfied. And there are 4 image. That means range is 4. Codomain also 4. This is called domain. Set B is called codomain. Codomain having 4 elements. Range also 4. Then it is satisfy the onto condition. That means F is 1 to 1 and onto. Then F inverse is exist. How to write F inverse? Here F inverse equals A comma 1, B comma 2, C comma 3, D comma 4. In the F function, first and second component order we need to interchange. That is F inverse. Here first component are said to be domain of F inverse. Second component 1, 2, 3, 4 are said to be range of F inverse. So what can we understand through this example? Domain of the function will be range in F inverse. Range of the function F will be domain of the F inverse. Range and domain will be interchanged in the inverse function. Okay, so inverse function means it has to satisfy the bijection conditions. Then inverse is exist. If F is bijective, then inverse is exist. Now constant function. Function F from A to B is said to be a constant function if all the elements of the domain are assigned to a single value in its codomain. F of x equals C, where x is belongs to A, C is belongs to B. I will show you. If you look at this is x-axis, this is y-axis. One function I am taking. The function f of x equals 2. I am substituting x plus 1. Whatever you substitute in the x place, you are getting answer is 2. So when you substitute 1 also, answer is 2. When you substitute 2 also, answer is 2, 2 comma 2. When you substitute 3 also, the value is equal to 2. When you substitute 4 also, the value is equal to 2. So 1 comma 2, 2 comma 2, 3 comma 2, 4 comma 2, 5 comma 2, 6 comma 2, minus, if I take minus 1 also, the answer is 2 only. Minus 1 also answer is 2. Minus 2 also answer is 2. You take any value for the x, the answer is equal to 2. When you join all the points, you will get the line like this. Now, this line is parallel to x-axis. Okay. See, the function f 1 comma 2, 2 comma 2, 3 comma 2. Here look at the range. Domain is changing, but range is same. Means these are belongs to set A, but this is belongs to set B. Set B having only one element. Set A, you can take 1, 2, 3, 4, 5 till infinity, minus 1, minus 2, minus infinity. But range is 2. So, what does it mean? Take any element. 1, 2, 3, all are associated with only single element. So, domain is different, range is same. Then you will get one straight line. This is constant function. For the value of x, where x belongs to set A, you are getting constant value, that is in the set B. Imagine this is set A, this is set B. Take any value, the answer is same. Then you will get one straight line. Okay. The range of constant function is a singleton set. Look at this range. It is only one element. The number of possible constant function from A to B is nothing but number of B. See, suppose here only one element, means how many constant function I can create? Only one. Suppose here one more element is there. One can relate with A, 2 can relate with A, 3 can relate with A, that is one function. Or 1 can relate with B, 2 can relate with B, and 3 can relate it with B, that is another function. That is also constant. Okay na? If all 1, 2, 3 related with A, you will get one line. Or all the elements 1, 2, 3, if they are related with B, that is also constant function. So what you are telling? If all these are related with 1, 1 also related with 1, 2 also related with 1, 3 also related with 1, 4 also related with 1, 1 comma 1, 2 comma 1, 3 comma 1, 4 comma 1, you will get one more straight line. Yes or no? So this is one function, constant function. This is another function. So how many constant functions I can make, that is depending on number of elements in the set B. If set B has only one element, I will get one constant function. Set B has 2, I will get 2 constant function. Remember, constant function just one straight line. Okay na? And it's parallel to x-axis. Next, identity function. A function f from A to A, remember this, from the set A to set A itself, is said to be an identity function on set A if f of x equals x. Very important. Here we are doing from A to A, and condition, the function f of x should be x. What you are taking input, output also must be same. Such function is said to be identity function. Yeah. And identity function, it is denoted by IA. Suppose you are taking set A means IA. If you are taking set B to B means IB. Suppose you are taking set X to X means IX. Second note, identity function is bijection. Means it is one-to-one condition and on-to condition satisfied. One example, from natural number to natural number, I am taking f of x equals x. This is condition for identity function. This is natural numbers, 1, 2, 3, many things. If your input is 1, output also 1. Input is 2, output is also 2. Input 3, output also 3. Similarly, you continue. This is natural numbers. This is also natural numbers. So my input is 1 means output also 1. 2 means output 2. 3 means output 3. So this is one-to-one function. every element associate with different element. In set B, this is set A, and range and codomain are same, it is onto. Then this function f is said to be bijection. So identity function means the function must be bijection. Identity function has its own inverse. Suppose if I consider this is a function, next I will show the example, you may understand. Remember, in identity function, inverse will be same as the function. So f and f inverse both are equal. Here I am taking set A containing 0, 1, 2, 3 all positive numbers, -1, -2 all negative numbers. My function f of x equals x, where x belongs to set A. We are making the function from A to A. The condition is that only. The function must be A to A. Fx must be equal to x. So, as per the condition, if I take 1 to the function, I am getting 1. So 1 is related with 1. If I take 2, I am getting 2. 2 come 2. If I take -1, I am getting -1. What is input? Output also same. -2 if I am taking, output is -2. If I take 0, 0 I am getting. This is my function. It will continue. There is no end. Then, is this 1 to 1 and on to? Yes. Different element having different image. If I take -1, I am getting -1. Set A is nothing but integers. 0 is related with 0. 1 is related with 1. 2 is related with 2. -1 related with -1. -2 related with -2. Whatever you are taking input, output is same. 1 to 1 and number of range and codomain are equal. Then it is onto. Then f is said to be bijective. When f is bijective, then inverse is exist. Inverse, just we need to change the order of first component and second component from the function f. Even if you interchange the component, answer will be same. That's why in identity function f and f inverse both are equal. Okay. Now let us understand how the graph will be there for this function. This is x-axis, y-axis. If I take 0, I am getting 0. 1 means 1. If I take 2, I am getting 2. 3 means 3. 4 means 4. -1 means -1. -2 means -2. If I join all the lines, the line is passing to the origin. Okay, na? This is identity function. Here both first component and second component will be same. Domain, range will be same. This is identity function. Next, what is equal function? The two functions f and g are said to be equal if and only if they are defined on the same domain. So f function and g function are said to be equal when both functions' domain should be same and f of x value must be equal to g of x. Means each domain should be same and their images also should be same. Then the f function and g function are said to be equal function. Condition: domain must be same and their images of each equal domain f and g, whatever domains we are taking, they should have same image. Then the function f and g are said to be equal function. Okay. Means suppose f function, I am defining f of x equals x, g of function is also x. Here x is natural number, here also x is natural number. Means both function domain is natural number, so domain should be same. Now if I take 1, I am getting 1. Here also 1, I am getting 1. So f of x, g of x will be same. If I take 2, I am getting 2. In g function also, if I take 2, I am getting 2. Domain should be same for the two function and range also should be same for the same domain. Then the function f and g are said to be equal function.